Got an upset stomach? Chem 103, Preparatory Chemistry at Ferris State University by Peter Belanda. The purpose of this experiment is to determine the concentration of an aqueous sodium hydroxide solution, NaOH, by titration of a known hydrochloric acid solution, HCl. We can think of titration as the careful addition of just enough reagent to complete a chemical reaction. Before continuing, think for a moment about what this process might look like. How can we calculate the concentration of the base? What allows this to be true? What do we need to know to make this work? Pay close attention to the actions taken in this video. Record your observations. As the video proceeds, questions will appear. Pause and rewind the video as needed to answer the questions using the corresponding lab submission form. Pause now and make sure that the correct decomposition of "got an upset stomach" lab submission form is open in another browser tab. Question 1. What was the first solution added to the test tube? A. 0.1 molar HCl, B. 1 molar HCl, C. sodium hydroxide A, D, sodium hydroxide B, E, 1% phenolphthalein. Question 2. How many drops of this solution were added? A, 18 drops, B, 19 drops, C, 20 drops, D, 21 drops. Question 3. What was the second solution added to the same test tube? A, 0.1 molar HCl, B, 1 molar HCl, C, sodium hydroxide A, D, sodium hydroxide B, E, 1% phenolphthalein. Question 4. What was the appearance of the contents of the test tube after the second solution was added? A, cloudy but colorless, B, clear and colorless, C, cloudy and pinkish or red in color, D, clear and pinkish or red in color. Question 5. What was the third solution added to this same test tube? A, 0.1 molar HCl, B, 1 molar HCl, C, sodium hydroxide solution A, D, sodium hydroxide solution B, E, 1% phenolphthalein solution. Question 6. How many drops of this final solution were added? Jot this number down. You will need it for calculations. A, 45 drops, B, 46 drops, C, 47 drops, D, 48 drops, E, 49 drops, F, 50 drops. Question 7. What was the appearance of the contents of the test tube after the end point was reached, after addition of the third solution was complete? A, cloudy but colorless, B, clear and colorless, C, cloudy and pinkish or red in color, D, clear and pinkish or red in color. Question 8. During the course of the titration, the contents of the test tube were frequently mixed by agitation. What did mixing during the titration accomplish? Mixing, A, kept the solution from boiling, B, reversed the color changes that began to appear, C, distributed the color evenly throughout the tube, D, dissolved the precipitates that formed. Question 9. Did mixing become more or less frequent as the titration continued? A, less frequent, B, more frequent, C, no change in frequency. Question 10. Had the solution not been agitated to mix the contents, it is likely that blank base would have been added. A, not enough, B, too much? C. The wrong. Question 11. The end point is reached when all of the blank present in the acid solution has been neutralized by the addition of base. At this point, when no more acid remains, the base reacts with the phenolphthalein indicator, causing the color to change. A. Hydronium. B. Hydroxide. C. Water. At this point, it's best to redo the titration to test our precision. If the numbers come up the same, we can simply average them. If they differ by more than a couple of drops, we'll have to repeat until we are consistent. In that case, we'll throw away any outliers, results that differ significantly from the others, before finding the average. Question 12. Why was it okay to rapidly add the first 40 drops without mixing? A. The same number of drops of acid were added as in the first trial, so the same number of drops of base should be required. B. When drops are added rapidly, mixing occurs on its own. C. It's always okay to add the base without mixing. Question 13. How many drops of titrating solution were added in total? Jot this number down as well. A. 45 drops. B. 46 drops. C. 47 drops. D. 48 drops. E. 49 drops. F. 50 drops. Question 14. Find the average number of drops. If you don't end up with a whole number of drops, keep one digit after the decimal. A. 46 drops. B. 46.5 drops. C. 47 drops. D. 47.5 drops. E. 48 drops. The balanced equation for the neutralization reaction is 1 HCl plus 1 sodium hydroxide yields 1 water plus 1 sodium chloride. 1 mole of HCl reacts with 1 mole of sodium hydroxide. We have the following conversion factors: 1 mole of HCl over 1 mole of sodium hydroxide, and 1 mole of sodium hydroxide over 1 mole of HCl. If both the HCl and the sodium hydroxide solutions were the same concentration, the same molarity, then 10 drops of sodium hydroxide solution would neutralize 10 drops of HCl. Likewise, if the concentration of the acid was twice that of the base, then 10 drops of acid would require 20 drops of base for neutralization. We can find the concentration of the sodium hydroxide solution by using the following relationship. C sub acid times V sub acid equals We can find the concentration of the sodium hydroxide solution by using the following relationship. C sub acid times V sub acid equals C sub base times V sub base, where C sub acid is the concentration of the acid in moles per liter, or molar. V sub acid is the volume of the acid in drops. C sub base is the concentration of the base in moles per liter, or molar. V sub base is the volume of the base in drops. Rearranging this, we get C sub base equals C sub acid times V sub acid over V sub base. Question 15. Calculate the concentration of the base used in the first titration. A. 0.45 molar. B. 0.44 molar. C. 0.43 molar. D. 0.42 molar. E. 0.41 molar. It's time to titrate a different base. This time, keep track of the acid used and the number of drops, the base used and the number of drops for 2 titrations. Then you'll be asked to calculate the average number of drops of base used and report the final concentration of the base. For the second set of titrations, how many drops of HCl solution were added to the test tube each time? A. 20, B. 21, C. 22, D. 23, E. 24. Question 17. What solution was used to titrate the HCl in the second set of titrations? A. 0.1 molar HCl, B. 1 molar HCl, C. Sodium hydroxide A, D. Sodium hydroxide B, E. 1% phenolphthalein. Question 18. For the first of these last two titrations, how many drops of this final solution were added? A. 20 drops, B. 21 drops, C. 22 drops, D. 23 drops, E. 24 drops, F. 25 drops. Question 19. For the second of these last two titrations, how many drops of this final solution were added? A. 20 drops, B. 21 drops, C. 22 drops, D. 23 drops, E. 24 drops, F. 25 drops. Question 20. Calculate the concentration of the base used in the second set of titrations. A. 1.0 molar, B. 0.95 molar, C. 0.87 molar, D. 0.85 molar, E. 0.80 molar. That completes the main part of the laboratory, but here is a final thought puzzle. You are asked to recommend the purchase of one of 3 different bases to neutralize an acid spill at work. You test small samples of each against the acid that was spilled. Here's the cost analysis. Brand X cost 1 cent per drop and required 25 drops to neutralize the acid. Brand Y cost 2 cents per drop and required 10 drops to neutralize the acid. And brand Z cost 3 cents per drop and required 8 drops to neutralize the acid. Question 21. Which brand is more economical? A. Brand X, B. Brand Y, C. Brand Z. That's all, folks. Thanks for joining. Double check your answers on the Got an Upset Stomach lab submission form and submit it for grading.